Hello, in this lecture I will prove the Pythagorean theorem. The Pythagorean theorem relates to right triangle, like this triangle in the right side of the picture. A right triangle is a triangle in which one of its angles is 90 degrees. This triangle has one angle that is 90 degrees. This angle is 90 degrees, so it is a right triangle, and the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The square of the hypotenuse is c squared and is equal to the sum of the squares of the perpendiculars, that is a square plus b square, or c square equals to a square plus b square. Okay, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. C square equals to a square plus b square. In order to prove it, I actually made a copy of this right triangle in the right side of the picture. I made a copy of it in the left side of the picture, and I actually made side B on the same straight line of side A, so side B is along side B in the same straight line, and then I raised a perpendicular to side B in size of side A. So the angle between side A and side B in the left triangle equals to 90 degrees. So we have here two triangles, two right triangles that equal between them in two sides. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle. And also the angle between side A and side B in the right triangle equals to the angle between side A and side B in the left triangle. Okay, so these two triangles coincides to each other because they have two sides that equal to each other, and also one angle that equals the angle in the right triangle is 90 degrees, and also we have angle that is 90 degrees in the left triangle. So these two triangles are coincides to each other, or the right triangle coincides to the left triangle. Okay, and actually the third side must be also side C, because those two triangles coincide to each other, and according to the rule of corresponding sides in coincides triangles are equal to each other. For this reason, if the third side of the right triangle is side C, it must be also side C in the left triangle, because those two triangles coincide to each other. And suppose that and suppose that we call to the angle between side B and side C in the right side of the picture alpha. The angle between side B and side C in the left triangle will be also alpha, according to the rule of corresponding angles between coincides triangles are equal to each other. Okay, and suppose that we will call to the angle between side A and side C x. For the same reason, we can say that the angle between side A and the side C will be also x, but I will not write it here. But we don't know the size of this angle, so we will call it x. So, but we do know that the sum of the angles in a triangle is 180 degrees, so we can say that alpha plus 90 degrees plus x equals to 180 degrees. So we will write it down. Alpha plus 90 degrees plus x equals to 180 degrees. Okay, the sum of the three angles in the right, the triangle in the right side of the picture is 180 degrees. It is correct for every triangle in the world. The sum of its three angles is always 180 degrees, no matter which triangle is. Now we will subtract 90 degrees from both sides of this equation. So we got that alpha plus x equals to 90 degrees. We will subtract alpha from both sides of the equation, and we will get that x equals to 90 degrees minus alpha. Okay, x equals to 90 degrees minus alpha. Now, if we look at the middle triangle, in the middle triangle, we don't know the size of this angle, so we will call it y. But we do know that the sum of the angles on one side of a straight line is 180 degrees. So x plus y plus alpha is 180 degrees. Because every line has two sides. It has the upper side, this is the upper side, and it has also the bottom side. The angles, the sum of the angles in the bottom side is also 180 degrees. In total, if we look in the bottom side and in the upside, the total, the sum of the all angles is of course 360 degrees. So now we look only on the upper side of the straight line, this straight line. So the sum of the angles x plus y plus alpha equals to 180 degrees. So we will write it down. The sum of the angles in the upper side of the straight line is 180 degrees. But so x plus y plus alpha equals to 180 degrees. But we know, we found out that x equals to 90 degrees minus alpha. So we can substitute x by 90 degrees minus alpha. So here we got that 90 degrees minus alpha plus y plus alpha equals to 180 degrees. But plus alpha minus alpha is equals to 0. So we can eliminate alpha from the equation. So we got that 90 degrees plus y equals to 180 degrees. Now we will subtract 90 degrees from both sides of the equation, and we will get that y equals to 90 degrees. Y equals to 90 degrees. So we know that this angle is 90 degrees. Okay, so we'll write it and actually the middle triangle is a right triangle because it has one angle that is 90 degrees. So actually we have here three triangles that all of them are right triangles. The triangle in the right side of the picture is a right triangle. The triangle in the middle is also a right triangle, and the triangle in the left side of the picture is also a right triangle because we built it like this. After we built side B, we raised a perpendicular to side B in size of side A. So here it is 90 degrees. Okay, so now we have here a trapeze. A trapeze is a square which has two sides that parallel to each other. Here two sides, A and B, are parallel to each other. If you have a square in a pair of sides that are parallel to each other, then it is a trapeze. So we have here a trapeze, and actually we will calculate the area of the trapeze in two ways, and then we actually will have two expressions, and we will say that expression 1 is equals to expression 2. This will be the third equation, and from that third equation we will derive the Pythagorean theorem. Okay, so we'll start with the first step. We will calculate the area of this trapeze. We will call the area of the trapeze S. So S equals to the sum of the parallel sides, that is to say A plus B, times the height of the trapeze, that is also A plus B, all divided by 2. So the first way to calculate the area of the trapeze is this way. So it is the sum of its parallel sides, that is A plus B, times the height, that is also A plus B, and all divided by 2. Okay, so this is the first equation for the area of the trapeze. Now we will calculate the area of this trapeze in a second way. We can say that S equals to the sum of the areas of the three triangles that the trapeze consists of. That this trapeze contains three triangles: the right triangle, the middle triangle, and the left triangle, and the sum of the areas of those three triangles will be the area of the trapeze. So we will calculate the area of the right triangle in the right side of the picture. The area of a triangle is the base times the height to the base divided by 2. So the base of this trapeze is A times the height to the base, that is B, divided by 2. So the area of the right triangle is A times B divided by 2. Now the area of the middle triangle is also the same formula, is its base times its height, or the height to the base, divided by 2. So the base of the middle triangle is C, and the height to the base is also C. It is the height because it has 90 degrees between these two sides. So it is C times C divided by 2, or C squared divided by 2. And the area of the left triangle is also the base of the triangle, that is B, times the height to the base, that is A, divided by 2. So it is B times A divided by 2. Okay, so we actually calculated the area of this trapeze in a second way by saying that the area of the trapeze is actually the sum of the areas of the three triangles that the trapeze contains. Okay, it is the area of the right triangle, that is A times B divided by 2, plus the area of the middle triangle, that is C squared divided by 2, plus the area of the left triangle, that is B times A divided by 2. Okay? Because we calculated the area of the trapeze in two different ways, we can say simply that equation 1 equals to equation 2, or expression 1 equals to expression 2, because it is the area of the same trapeze that is calculated in two different ways. So we can say that A plus B times A plus B divided by 2, it is the area of the trapeze when we calculated it in the first way, is equals to the area of the trapeze as we calculated it in the second way. So expression 1 is equals to expression 2. So it equals to A times B divided by 2 plus C times C divided by 2 plus B times A divided by 2. So expression 1 equals to expression 2, or the area of the trapeze as we calculated it in the first way is equals to the area of the trapeze as we calculated it in the second way. And here actually we can multiply the equation by 2. Okay, now we know that AB plus BA is 2AB and C times C is C squared. So we will write it down. Okay, AB plus BA equals to 2AB and C times C is C squared. And in the left side of the equation we have a bracket, so we will open the brackets and do the multiplication. So after we open the brackets, we got that A times A is A squared, B times A times B is AB, B times A is BA, and B times B is B squared. All equals to 2AB plus C squared. Now we know that AB plus BA is 2AB, so we will write it down. So we got that A squared plus 2AB plus B squared equals to 2AB plus C squared. Now we can subtract 2AB from both sides of the equation. So the final result is that A squared plus B squared equals to C squared, and this is exactly the Pythagorean theorem that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or C squared equals to A squared plus B squared. Again, the square of the hypotenuse is equals to the sum of the squares of the perpendiculars. C squared equals to A squared plus B squared. Okay, now I will summarize the proof. Actually, we have a right triangle. A right triangle is a triangle in which one of its angles is 90 degrees, and we have to prove that the square C square, or the square of the hypotenuse, is equals to the sum of the squares of the perpendiculars, equals to A squared plus B squared, or C squared equals to A squared plus B squared. In order to prove this equation, actually I made a copy of this triangle here on the same straight line of A. I built side B, and then I raised a perpendicular to B in size of A. So we have here also the angle between side A and side B is also 90 degrees. So actually we have two coincide triangles, and for that reason this side is also C, and then we actually found the triangles, the angles, and we found out actually that this angle equals to 90 degrees. So we have here three right triangles, and then we actually calculated the area of this trapeze in two ways. A trapeze is a square with two sides that are parallel to each other. Side A is parallel to side B. So we made the calculation of the area of this trapeze in first way. We say that the area of this trapeze is actually the sum of its parallel sides, that is A plus B, times the height of the trapeze, that is also A plus B, divided by 2. This is the first way of calculation of the area of the trapeze, and we can calculate the area of the trapeze, and we can say that the area of the trapeze is actually the sum of the areas of the three triangles that the trapeze composed of. The trapeze composed of the right triangle, and it composed of the middle triangle, and it composed of the left triangle. And the sum of the areas of these three triangles is equal to the area of the trapeze. So this is the second way of calculation of the area of the trapeze. When we found out that the area of the right triangle is A times B divided by 2, and the area of the middle triangle is C times C divided by 2, and the area of the left triangle is B times A divided by 2. So we multiplied it by 2. We developed this equation, that the expression 1 equals to expression 2, because it is the area of the trapeze that is calculated in two different ways. So it is the same area, but that is the reason that expression 1 is equals to expression 2. So we developed this equation, and we got the final results that says that A square plus B square equals to the C square, or the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Okay, the square of the hypotenuse, C square, is equals to the sum of the squares of the perpendiculars, that is A square plus B square, or A square plus B square equals to C square. Okay, thank you very much.